Hello guys, welcome back. In this video, we will learn about few more AWS services by solving a real-time problem. Let's say my client is having a multiple fuel stations. Now, client is getting the data regarding the fuel present in their fuel stations at, at the end of the day. Now, during the scenario, what happens is, so sometimes the fuel may finishes, even the customers may face the issue of empty fuel at their fuel stations. So it might lose the of that company regarding the fuel, whether there may be fuel is present or not. So that that was not acceptable by customers, right? Yes. So customers will think like where the fuel will be, in that station only they will need to move. Other stations there may be fuel or there may not be fuel present in that fuel stations. So those fuel stations will be avoided by the customers mostly. So now my friend or the user came to me, now the client came to me and asked that I want a system to know in every minute, so where do any fuel station require fuel, that is, do any fuel station require fuel, that means do any fuel station will leads to, that means the fuel present in any fuel station will becomes empty or not. If it leads to less, that means if it becomes empty, then we need an exact time, that is, at any fuel station, if the fuel is less than certain limit, then we need immediate response. We need to know immediately the message, and we need to proceed with the fuel tankers, and we will send the fuels to that fuel station, right? Yes. So in order to get that status, get that data immediately, how to do that? So for that, now in this video, we going to solve that scenario. Let's say we have a fuel station and we need to know that multiple fuel stations related data. I have station 1, station 2, like that multiple stations are there, and those stations related data regarding fuel amount, so that will be provided by fuel stations in real time. So these fuel stations will maintain their own servers, that is their own systems, to provide that fuel status to me every day at the end of the day. But now, due to my requirement, I need to get every 10 minutes the information. So that's why my fuel station managers, so who are managing the fuel stations of mine, they will be providing that data in every 10 minutes, or even whenever they require, whenever their fuel in the fuel station will be less than the amount that I specified. So then they immediately provided that feedback in the server, in their own servers. Then I need to get that response immediately, and I need to resend the fuel to that particular station immediately. So that's what I want to do. For that, I want to create an architecture at first, then I want to implement that architecture in cloud to do that. Now let's talk about the architecture at first. That is the, let's talk about the implementation plan. Now every fuel station will generate some data, right? Yes. So whenever they require, they will generate some data, and they will send they will include that data in their servers, in their own servers, they include that data. Now, at backend, where do we actually store that data? Since we are getting every few minutes, we are getting the data, right? Yes. So to efficiently store the data, we are using here a data lake. So what service we are using as a data lake in AWS here? Now we are using AWS S3 as a data lake service to store that lake of data that was produced by fuel stations. Not only one station, there may be multiple stations. So I want to manage that whole data, right? So for that storage, I want to use this S3, right? Yeah. Whenever the data is updated at fuel station, then immediately I want to stream that data. I want to put the data into my data lake, that is S3, right? Yes. So for streaming that data, so whenever my manager who is present at my fuel station put that record, put a new record into some service, and that service need to put that records into my S3, right? Yes. So to do that, so here we are using one service, one streaming service to put the records. Whenever they put into the stream, that data need to put into this S3 when every time. That can be done by using this Kinesis Data Firehose. So whenever manager put that data into this Kinesis Data Firehose, then that data will be immediately moved to this destination, that is S3. We can do that by using this Kinesis Data Firehose, right? Yes. So actually managers put the data in their servers. So whenever they put the data in this, then Kinesis agent we install in that server in real time. So that will put the data into this Kinesis Data Firehose. Then this Kinesis Data Firehose will move the data into the destination, that is a data lake that we are using as now S3. Now for this lab, to generate the data, I don't want to use a server for this. I'm expecting to use one serverless compute service, that is a Lambda. I want to use Lambda for generating some random data. So to generate some random data regarding fuel stations, fuel, I'm using this some Lambda code to generate that. Then after I'm putting that data immediately into my Kinesis data firehose. Then after this Kinesis firehose will move the data into the destination, whatever the destination that we configured. So after storing my data in S3, I need to analyze that data, right? I need to know which station fuel status is less than the expected. Which station, which fuel station fuel is less than the expected, that I want to analyze, right? Yes. So that actually you can analyze in real time. That actually, if you are a AWS engineer, then you can analyze that by using a service, that is Athena service. By using Amazon Athena service, you can query the data which is present in S3 directly, and you can able to analyze that data, right? Yes. So but now in real time, so everybody do not use this Athena, right? Yes. So in real time, what happens? We need an application to perform this querying action automatically. To perform this querying action, we need a service, right? Yes. So what is that service that we are going to use, sir? So for that compute purpose, we are going to use this Lambda function. So for that purpose, so in order to query the data present in this, S3 that we store, so that we can query by using one Lambda function code. In this Lambda function code, we actually write the query. Where that query actually executes in Athena only. We are using this Athena service to query the data present in S3 by using Lambda function. We will run a code in Lambda function where in that code we will implement this Athena function to query this data and provide the response. Let's name these Lambda functions so that we can easily understood this. So to generate this fuel related status, so I am naming this Lambda function as gas station app. And to analyze the data stored in S3 data lake by using Athena queries, I'm using one more Lambda function, right? So I'm calling this Lambda function like fuel planning app. I'm calling this Lambda function as fuel calling app. So then after I'm getting the status regarding, so whatever the gas stations which are having a less fuel status than I'm expecting. So in this Lambda function, I got those details. Now what I want to do, I want to implement one more app, right? So I want to implement one more app in order to tell this fuel planning app will generate me the status regarding which gas stations have less fuel than required, right? Yes. So in order to deliver the fuel to those stations, I need to inform that to my delivery boys, right? Yes. So to inform this status to my delivery boys, I need one more app, right? Yes. So I'm using here fuel truck app. So this fuel truck app will take each and every request. So it will take each and every request from this Lambda function, and this app, fuel truck app, need to deliver each and every request to any one of the delivery boy, or yeah, any one of the delivery boy. So in between, no request need to be unprocessed. That means let's say I have 3 stations. So these 3 stations require fuel. Those are having a less fuel than required. So then that data will be entered by managers. That will be immediately put into, that data will be entered by managers into their servers. That data will be immediately put into this Kinesis data Firehose by using the agent that we installed in it in real time. And that data that is put into this Kinesis data Firehose, that will be immediately moved to this destination, that is S3 bucket, that is data lake. Then immediately this Lambda function will query whatever the data. So immediately whenever a data put into this, then this Lambda function is triggered, and this Lambda function will query the data which we put into this data lake, that is S3, by using Amazon Athena queries. Then after it will find out which stations, which gas stations, which fuel stations will have less amount of fuel data. So that each and every station, it need to send that fuel by using delivery boys, right? Yes. So whatever the response it generates, that each and every response will be executed by this Lambda function. No response need to be unexecuted. If let's say one response is unexecuted, let's say whatever the request sent by third gas station was not executed by using this Lambda function due to some event failure. So then what happens? Obviously, there will be no service available, right? Yes. So in order to avoid that, we need a service. We need a service in between where it can able to process the data which we put into that. It can able to process, it must need to process that data at least once. So at least once before deleting that data, it need to process the data. So I need a queue service in between to process that data at least once before deleting that. So for that, we have a service that is SQS. So we are using simple queue service in between for that in order to implement that. So we put the data, we generate the results from the Lambda function and we put the data inside this SQS queue. Then this SQS queue will be will provide each and every message to this Lambda function. Whenever this Lambda function is executed, then at that moment of time, this SQS queue will send whatever the messages that it has to the Lambda function, that is a fuel track app. So each and every time, whenever a message is delivered to it, then only the message will be deleted from here. So in this way, we can even avoid the that issue, that is a unprocessed messages issue. We can even avoid that unprocessed messages issue by using this SQS service. Now, in this lab, so this is the architecture that we developed. Now, to execute this architecture, in this lab, I've already created a Lambda function and I've already created one S3 bucket to store my data lake. And I've already created this Lambda function. So that is a fuel planning app and fuel truck app. Don't worry, I'll explain you that. And I also created this SQS service for you to implement. But now we focus on these things. That is a Amazon Kinesis Data Firehose. I want to use this service as a streaming service. So in order to stream my data, whenever a user put my data into this stream, then how to deliver that to another service, that we focus majorly in this lab session, and all the other things will be pre-configured. Don't worry, I'll explain you each and everything about this project end to end. Now let us create this Amazon Kinesis Data Firehose. Now let us create this Amazon Kinesis Data Firehose to put the stream, that is for stream injection to my data lake. For stream injection to my data lake, I want to create this Kinesis Data Firehose. For that, I've already logged into my AWS Management Console. Now I'm just clicking on, I'm opening this Kinesis. I'm opening this Kinesis service. I'm searching for it. You can see we got this. I'm opening this Kinesis service. Now in this Kinesis service, we have Kinesis Firehose option. We can open it from here or else directly from searching also we can get that Kinesis Firehose. You can see here under getting started, we have Amazon Data Firehose, formerly Kinesis Data Firehose. So that we're gonna use to process and deliver the stream data with Firehose stream. So now I'm just clicking on create. After selecting that, I'm clicking on create so that it can open me the Kinesis Firehose streams. Right? You can see it was opened me the Kinesis Firehose streams. Now here you need to configure the details regarding source and destination. So what is the source? Actually, whenever we put our data, so during that moment of time, it need to stream the data and move the data to the destination, right? Yes. So what is our destination or data lake? What is the data lake? S3 we are using as data lake. So that's why I selected destination as S3. And what is our source? So direct put is our source. So whenever we put directly, so that is our source. So we are using this direct put option. Now we need to provide some name for this stream. In order to identify that, we need to provide some stream name. Since it's a injection stream, I'm providing the name of this as stream injection. So to ingest my stream to S3, so I'm providing the name of it as stream injection. Now So in middle, if you want to transform and convert your record, so after putting your data, that is after your source will generate your data, before you put your data into your destination, if you want to provide any transformation and provide any conversion to your records, then you can do that from here. So actually I want to convert the record, because if you convert the record from normal CSV file or any format of file to this Parquet, then it might take you very less amount of charge to process by using Athena queries. So if you see the Athena related lab, then there you analyzed that practically. So that's why I'm converting my data, either CSV or JSON format of data, to this Parquet file. So that's why I chosen this. Now to convert, we need to specify the schema of our source records as well. So how to specify the source record schema, sir? So for that, I have already created one glue, which is present in North Virginia region. Now I'm using the conversion glue database. So that also contain one table. You can browse and get that. You can see that is conversion table. I'm choosing this. You can even watch this by opening your glue service. I'm opening glue to show you that. So I searched for glue and I'm opening this glue data catalog just for to show you that database, and inside that database I want to show you the table, so that's why I'm opening this. You can see under data catalog database tables, so you can even see the database name, that is conversion. So inside that conversion I have this conversion table. So for this conversion table I have already provided the schema of my data. So now I'm moving back to my Firehose. Now we are in this step. Yeah, we provided this transform and convert records step. We finished this. Then now we are under destinations step. Now at where, in which destination you want to store your data, that you need to configure. Actually, I'm already having some buckets in consumption bucket. In consumption bucket, I actually want to store my data. So I've already created this Athena output bucket for to store my Athena output results. Now to store my streaming data into S3 bucket, I have stored in this consumption bucket. So I'm choosing this bucket. I'm even opening and showing you that in S3. Yeah, currently we not have any objects in it. Now I'm using that. I'm choosing that. You can see that was chosen. Yeah. So now, if you want to provide any partition, yes. So if you provide partition, then it might be very easy to query your data. So that's why I'm enabling this partitioning. That's why I'm enabling this dynamic partitioning. Now, I'm also enabling inline parsing as well. Here we need to provide the records regarding our data. So here I'm just copying this data and pasting it there. So in this way, we need to provide the partitioning data actually. So that I'm providing here. In my input, I'll provide station ID, not customer ID. So I have multiple stations, right? So for each station, I have a station ID. So this, I want to put it like a dot station ID. And I also even provide these things, that is in which year I'm sending, in which month, in which day, in which hour also I'm sending. So those all details that I'll provide. So that's why I'm adding few more partitioning keys. So based on these partitioning keys only, your data will be partitioned. So I'm providing this year, month, and day. and hours also I want to provide. So based on that, so those many folders will be created. The outermost folder is this and the innermost folder is this. So that we need to provide the partitioning prefix here. So that I will show you after providing the details of it. Now I'm providing the year, then month. So month M will be specified by small m, and day, that is small d, and hour, that is capital H. So like this, I provided this argument, that is for these keys, for these key names, I am providing these values. Actually, these queries will be executed and we got the response. Those will be stored in these variables. So for these variables, now I am providing here. So in station, in particular station ID, I want to store in particular station. Since I'm storing station related data, so that's why I provided station data is the outermost folder. Inside that, I'm providing the partition key of my query data. Partition key from query. So first, which query I want to provide? I want to provide a station ID. So topmost folder is a station ID. Then I need to provide this for every folder. So after this station ID, I will choose the year. So as my partition key, I'm choosing this year as my partition key. Then after, I'm again choosing. Then after, I'm again choosing my partition query as month. So like that, I want to choose for days as well as hours as well. You can see I have chosen those two as well as my partitions. So like this, my folders will be like this. My folders will be actually created. I want to apply this partition. So I just clicked on this apply partition key. Now, if there will be any error, then I want to put it under this error folder. So that's why I provided this name, and retry will be 60 seconds is enough for me. And so that's it. You can just create firehose. So before that, if you want to analyze the details and buffer interval will be also 60 seconds is enough for me. Advanced settings under you have multiple data. Yeah. So you want to choose an IAM role that you can choose here to do that thing. That is to move to destination. You need to provide some access, right? Yeah. So you need even Kinesis Firehose access, right? So those all I have configured in this IAM role. You can open and see as well. I'm just opening it for you to show that. For this, I have created an inline policy so that I want to show you. You can see this. Yeah, this inline policy is loaded. Yeah. So in this, I provided some details like actions. I allowed get table, and from glue I allowed get table version and get table versions as well. And I also allowed the actions like S3 related actions. These all like putting a listing and getting and about a multi-part uploads. So only these actions I allowed, and I also specified the resources as well and effect as well. So in this I am go. Now I'm just moving back, and in finally I'm just clicking on create this firehose. I'm just clicking on create firehose. So now this firehose will going to create. So now the status you can see it is creating. right? Yes, you can even monitor the metrics in these dashboards, and you can even see the configurations from this tab. Destination error logs, if there will be any, then you can check from here. And these are the related details regarding your stream injection firehose that you just created. So now it was just a creating status. So now we completed this task, that is Kinesis Kinesis Data Firehose creation was done by us just now, right? Yes. Now let's wait till this becomes active. Now I'm just opening. You can see now the status becomes active. Its destination is S3 and source is a direct put. Under configurations, you can even see the transformation that you provided. Here you just converting whatever the data records that we put into it into Parquet format, and then we are putting that data into my S3 bucket, that is this bucket. So that we have already seen previously, that is a consumption bucket. So currently I'm not having any data, right? Yes. Now let's check by using this Lambda function, that is a gas station Lambda function. Let us test whether this Kinesis data firehose that we created just now, that was working or not. So for that, I'm just copying the Kinesis firehose name. So whatever the name that I put, that I'm just copying. Now I'm just opening Lambda function. You can see I'm opening this in a new tab. Yeah. So now it is opening the Lambda function. Here I have multiple Lambda functions. So in that I'm opening the gas station app. So in this gas station app, I'm using one environment configuration. That is a one environment variable. So that is this delivery stream. So in order to provide it in front of you to show you how to provide, I'm just clicking on edit to replace this with whatever the stream name that I provided, and I'm just saving it. So like this, you can able to provide your environment variables that you use in your code in your Lambda function. While executing, if you want any environmental variables, you can see under os.environment, I'm using this delivery stream. So that delivery stream name that you just provided by using this configuration option under environmental variables, you configured the variable related value, right? Yeah. So you can keenly observe, that is you can clearly observe with this code. So here I'm just created the client for my firehose, and I'm just randomly generating some data by using some loop. Each and every time I'm generating some data by using loop, and I'm iterating over 10 times, and each and every time I'm generating some station list. You can see currently I've created an empty list, and after that what I'm doing is inside that list, I'm putting each and every time one JSON data. That JSON data will be randomly generated data. That is a tank level. Let's say I have 5 tanks. Let's say I have 5 levels, 5 tank levels. So for that each level, I'm generating some random data and storing that into this. And each and every time I'm creating one ID. That is from 1 to 10, the ID will be generated. So that will be stored in this station ID. And at last, I am appending that data, that is putting that data into this list. So after finishing this 10 times running of this for loop, what happens is into this stations list, 10 data records will be generated and that will be returned. So that we can see in the output after testing this. And in middle, we have written this code. So this code is actually to put the records into my Firehose client. That Firehose client we created by using this Boto3 library client function. We created this Firehose. So we created this client Firehose, and we get that delivery stream name from the environment variable, that is a delivery stream from here. Then we are using that delivery stream name in this delivery stream name, and we are putting the record that we just generated into this, and we are putting that whole record into the Firehose delivery stream that we provided. So into this delivery stream, whatever the name that we provided, into that stream our data will be actually putting was happening. Now I'm just expecting to run this and see whether in my destination folder, that is in my consumption bucket, my data is delivered or not. So if this was created successfully, then obviously whenever the data generated from Lambda function, that will be moved to this destination S3 bucket, right? Yes. So first I want to run this Lambda function. So for that, I'm just clicking on test, and here I'm providing as event one. So from some random event name that you need to provide. And first you need to save that event. Then you need to test this Lambda function by using that event. I'm running this gas station code. You can see a sample of 10 stations data will be generated, random data, and that will be even pushed to my S3 bucket. I'm just reloading this. I think it might take a few. Now I'm reopening this S3 bucket. Now you can see I'm refreshing it. Here you can see one bucket, one folder got created by using station data. Inside that, so what is the station ID? So based on that, our station IDs will be there. So since we generated only 10 station IDs, only 10 folders are created. So in first folder, first year will be came, and in this year, month will be came. In this, day will be came. In this, actually, your hour in what hour that will be performed. So that will be there. So in this, actually, the data will be there. So how many times that you run, so those many data will be present here. So that many data will be present here. And you can even check under monitoring session of your Lambda, whether your Lambda function is run successfully or not. From here, from these matrices, you can analyze that as well. So invocations, how many done? Yes. So how many invocations done? Or else from data Firehose also, you can even check that Firehose matrix as well. That is incoming bytes. So records successfully converted, how many records that are successfully converted? So that count. So like that, the data you can able to see from this data Firehose in order to analyze that your Firehose is working or not. So you can even see the destination error logs. If there will be any, then those will be generated here. Currently, no error logs will be generated because no error is there. So that's why no error log is generated till now here. Now let's move back to the architecture. That is, we have done up till here. That is first three steps was done. Now I want to analyze the data which is stored in S3 by using some Lambda code. By using Athena queries, I want to analyze the data by using some Lambda code. So that I've already provided by using fuel planning app, Lambda code. I'm just opening the Lambda function. So here I'm moving back to functions. So there I'm opening this fuel planning app. Here you can see under this fuel planning app. So I've already written the code. Yeah. So here also I'm using some environmental variables so that you can see under the configuration set tab. So here I've already provided that environmental variables. I'm opening and providing you the code. You can see in, so here I provided the query. So in order to execute this query inside my Athena, So I'm checking whether any tank level, so whether any station tank level is less than 200, that I am selecting and that I am storing as a result to my query. So for that, I've written the query. Now, what I want to do, I want to execute this query in Athena, right? So for that, I've created a client for Athena. Now, to execute the query, I'm using this start query execution function. So to execute that query, I'm using this start query execution function. There I've provided the query string as my query. So this query I have provided previously. So I stored in this variable so that I'm using this query variable here. And query execution context. So what is the database that also I provided by using this database variable. So this database variable will actually store my glue database name. Under OS environments, I configured this glue database variable details like a name. You can see under configurations tab under environmental variables, glue database name I have provided and glue table name I have provided, and output S3 bucket, in which output S3 bucket that will be stored. That is in Athena output bucket. I want to store Athena results, right? So that's why I provided this. And I've also told you that I've created an SQS queue for storing these messages. So that also I provided under this queue URL. So those all details I am picking from here by using this os.environmental environ and providing that particular variable name. And I'm using those inside my code. So here you can see in query execution context, I provided the database and result configuration I provided where I want to store my Athena result in my S3 output. I want to store my Athena result. So that's why I provided that as my output location. Then I'm taking the query ID. I'm taking the query ID from this query start. So from this query start, I'm taking the query ID by using this variable, that is query execution ID. And I just stopped the process for 3 seconds by using this time.sleep method. Then after, I've created one list, one empty list I've created, and I'm even taking the query results by using a get query results. By using get query results, I'm taking that query results based on the query ID that was previously taken. Then I'm retrieving the row headers. That is, you can see the first item related header I'm taking. So first I'm taking the rows related header. Then after I'm taking each and every value, every row, and I'm storing it as a station ID. You can see as a station ID, I'm storing the station ID and I'm sending that message to my queue. So I've provided that station ID to this function. This function will call this function call will reach to here. So whenever we call this function, then that call will reach to here. Here actually the message will be sent to your SQS queue and stored in your SQS queue. So here you can see I'm using this client send message. This send message. This client is nothing but I created a client for SQS queue and I'm using a queue URL to connect to it, and station ID I've provided to it as a body message. That body message will be saved in this SQS queue. Then that event will be printed here. So at last, so that will be happened here. So like that, how many station IDs will be there? So those many station IDs will be saved in my messaging queue. That is a SQS queue. And so for further process, I am storing that in this SQS queue. So by using this Lambda function code, what happens is actually it will query my S3 bucket by using this Athena query, and then it will take off whatever the station IDs which are having less amount of level, tank level than required. Here I'm providing the required level as 200. So that tank levels I'm taking So that station IDs I'm taking, and those station IDs I'm sending those station IDs to my message queue by using this send message option. Even I provided the queue URL in order to identify particular queue and to put my station ID in message body. I used this message body as equals to this station ID. So that's it. I'm just printing this station ID at last. Now let's run this and let's check whether that station ID got moved to, that is my data got moved to my SQS queue or not. Now I'm just running this. You can see test was is in process. You can see responses was generated. That is these many responses was generated. So totally how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So totally 12 messages got generated. These all station IDs will be saved in my SQS queue. You can open that and check that. So I'm searching for SQS. I'm opening it in new tab by clicking on control. And now after selecting that, it was opening my SQS queue. So here you can see fuel planning queue is there. So in this queue, you can see the messages. So how many messages are there in this queue directly from here? Directly from here itself, you can able to see how many messages are there. So totally 12 messages are there. That means these 12 messages we got from there. From where? From here. From here actually we got those all messages and stored here. So totally 12 station IDs were stored here. Totally 12 station IDs were stored here. Now at last what we have done, we have already executed this Lambda function as well. Then at last we have this Lambda function code to execute this to retrieve the messages which are stored in it. That is what station IDs that it has. Those station IDs I need to retrieve from this Lambda function and I need to provide it to my delivery boys, right? So for that I need to run this fuel truck app to get that data. So now I'm opening that fuel truck app Lambda function. Now I'm moving back to functions. You can see fuel truck app. So now I'm opening that. So for this also I configured the environmental variables. You can see that a queue URL I configured, and I'm using that queue URL from the environmental variables and storing it in queue URL, and I've created a client for my SQS queue. Then I'm using that queue URL and max number of messages that I want to receive and max wait seconds that I've provided. Here I have provided the receive message. Here I'm using this method, that is a receive message, and here I'm using this receive message. So by using this receive message, I'm executing this receive message command to receive max 10 messages and wait time, that is up to 5 seconds only I will receive. So if the time limit exceeded, then this receive message function will be stopped, or else max 10 messages will be received, this receive function will be stopped. So based on the two conditions I'm working this, and I'm retrieving all those messages. So in this receive message variable I'm storing those messages, and so by using this messages I'm getting that data from this receive messages and storing in m variable each and every time, so that I'm using that m variable to get the body from here, that is from which station I got that message that I'm printing here. And at last I'm generating a receipt and deleting that particular receipt handle, that is that particular message I'm deleting even from my queue, since that message even provided to my delivery boy, that gas station ID provided to my delivery boy, I need to delete it from my queue, right? Again delivering to that same station will be invalid. So that's why I'm deleting that station from my queue. And after that, you can say I'm finding the length, and at last these are just message statements that I am returning to print that message. So now I'm testing this. So to test this, I'm clicking on test, and now I'm just clicking on invoke. I'm just clicking on invoke. So that's what we just done previously as well to run this Lambda function. You can see messages, how many messages processed? Just 2 messages processed. So let's verify this 12 got reduced to 10 or not. That is it. 2 messages are processed. So 2 messages will be deleted from here. And I want to process the other as well. So that's why I'm testing this. Again, 4 got processed. So those 4 messages got reduced. Yeah. Now I want to process remaining. You can see again another 2 got processed. You can see, yeah, 2 got reduced. Now I'm again testing this Lambda function. Again, 2 got processed. I'm testing this Lambda function again. 1 more 2 got processed. So I think every messages got finished. So I think no messages will be there. Yeah. So 0 messages got processed. That means in my queue, all messages will be processed. So that's why again processing was not done. So this is how we implemented this whole architecture, and we resolve the issue regarding fuel station. So in this way, we can resolve this issue. That is, if you have multiple fuel stations or gas stations or any other multiple institutions, then if you want to provide your message immediately to the delivery boys. So first you want to save the data. For saving, we are using S3 bucket, and for stream injection, we used this Kinesis Data Firehose. So in order to process the data stored in your data lake, that is S3, we used this Athena queries. So to run this Athena queries, I created an app that is a serverless Lambda. I used this serverless Lambda to process this data. Then after, I used this SQS queue to store the data until that message got processed. So to process that data, I used this Lambda function to see what are the stations where the fuel is not there. So that stations will be stored under this SQS queue by using this Lambda function. So how do we get that stations? By using this Athena queries only we get that stations. Then after, at last we processed that data as well. We picking some messages, that is station IDs from this queue by using this Lambda function. And then we provided those IDs to our delivery boys. And at last we deleted that messages from this queue by using the receipt ID. So that's what we're gonna done in this video. So here in this video, you have learned an end-to-end project regarding how to implement this streaming injection by using this Kinesis Firehose. And in addition to that, you have also learned about SQS queue and Lambda functions need. So where do we use these Lambda functions? Whenever we require a compute, if you have any compute requirement. So in that case, serverless compute requirement for backend tasks, you can use this Lambda function. And Athena, why do we use this Athena? In order to query the data present in this S3 bucket. So by using SQL queries, we queried the data stored in S3 bucket. Why do we use this S3 bucket? We use this S3 bucket to store our data lake. So infinite data lake storing, we used this S3 bucket. So I hope you understood this concept of streaming injection, and you got a good knowledge regarding this end-to-end project. So I hope you got knowledge regarding this. I hope this video is useful to you. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.